What if I told you that the fighter jet you see slicing through the sky at twice the speed of sound isn't just a machine? It's a living, breathing monster of physics, pressure, fire, and raw power. And that one tiny miscalculation inside it could make the entire aircraft fall out of the sky in less than half a second. What if I told you that every time a pilot pulls the throttle forward, he isn't just flying? He's fighting gravity, drag, air pressure, shock waves, and the limits of human endurance all at once. And what if I told you that everything you think you know about how a fighter jet works is only the surface? Hello everyone, welcome back to Battle Tech. Today we're diving deeper than ever before into the complete beginner's guide to how a modern fighter jet actually works, how it flies, how it survives, and how it dominates the sky with physics so intense, so extreme, and so unforgiving that even the smallest mistake can turn into a catastrophic failure at 40,000 feet. Let's start from the moment a fighter pilot sits inside the cockpit. He isn't just entering a seat, he's stepping into a pressure-controlled chamber built to keep him alive while the outside world turns into a freezing, airless vacuum. Every system around him, every button, every switch, every warning light is connected to a hidden nervous system known as fly-by-wire, a computer-controlled network that decides whether the plane stays stable or rips itself apart from the force of the air. And then comes the heart of the beast, the jet engine. A fighter jet engine works by inhaling air at unimaginable speeds, crushing it down with brutal compressor blades, igniting it with fuel hotter than molten metal, and exploding it outward through the rear in a violent blast of superheated gas so powerful that Newton's third law kicks in with full rage, throwing the aircraft forward like a rocket. Every action has an equal and opposite reaction, and in a fighter jet, that reaction is pure thrust strong enough to send a 20-ton machine hurtling upward like a bullet. But thrust alone doesn't make a plane fly. For that, you need lift created by the wings, those elegantly curved structures designed with secret aerodynamic magic. As the fighter jet races forward, air splits across the wings. The air on top moves faster, pressure drops, and the aircraft is pulled upward with tremendous force. This is Bernoulli's principle in its most extreme, high-stakes form, the same law that keeps a paper airplane gliding, but turned into a weapon of war. But the faster you go, the deadlier the air becomes. Drag slams into the jet like an invisible wall, trying to slow it down, trying to stop it from breaking the sound barrier. But modern fighter jets are built with precision shapes, razor-sharp noses, swept back wings, and ultra-smooth bodies designed to slice through drag like a knife through water. And when a pilot needs more power, more speed, more life or death acceleration, he hits the afterburner. Fuel floods into the engine's exhaust, ignites into a second explosion, and erupts into a glowing tail of fire that rockets the aircraft past Mach 1, Mach 1, 5, even Mach 2, pushing the pilot back into his seat with crushing G-force that can reach 9 times his own body weight. Every turn becomes a battle against blackout. Every maneuver becomes a fight for consciousness. And yet, despite this chaos, the pilot has to remain calm, steady, precise. Because at these speeds, even the smallest angle change the angle of attack can determine whether the jet lifts or stalls. Too low and you fall, too high and the smooth airflow collapses, sending the jet into a deadly spin. But that's where modern technology comes in. Computers, sensors, and real-time stabilization systems keep the aircraft from killing itself. The jet isn't just flying, it's constantly correcting, adjusting, calculating, reacting thousands of times per second. And while all this happens, something even more invisible is at war with the pilot: air pressure. At 40,000 feet, the outside pressure is so low that human blood can boil. That's why the cockpit is sealed, pressurized, and constantly monitored. A single leak can be fatal. And yet the fighter jet must handle pressure changes, temperature extremes, sonic shockwaves, and violent crosswinds, all while staying balanced, fast, and responsive. As the jet roars through the sky, its wings are bending, flexing, twisting, managing tons of aerodynamic load. Its engine turbines are spinning at tens of thousands of RPM. Its sensors are reading the air, the ground, the horizon. And its pilot is fighting physics with skill, instinct, and courage that most people will never understand. Because flying a fighter jet isn't just about flying. It's about controlling a controlled explosion, riding a tornado, and balancing on a blade of air at speeds where the sky itself becomes a weapon. And that, right there, is the true power of a modern fighter aircraft, a perfect harmony of physics, engineering, and human will. If you enjoyed this deep dive into how fighter jets actually work and want more mind-blowing breakdowns like this, make sure you hit like, drop a powerful comment, and subscribe to BattleTech so you never miss our next high voltage video.